So, again we will go back to our basic equation. I bus is equal to y bus into V bus, and if we take any particular bus injection, then I k will be equal to summation y k n into V n. That is, if we go back and see here, then I 2 is this. If we look at this, this is I 2 is equal to y, or let me see from here. Yeah, I 2 is equal to y 2 1 into V 1 plus y 2 2 into V 2 plus y 2 3 into V 3. So, it is summation of y I k is summation of y k n into V n. So, this is what we have written here. I k is equal to summation n is equal to 1 to capital N, where capital N is the number of bus bars in the system. So, I k is equal to summation y k n into V n for n is equal to 1 to small n is equal to 1 to capital N. Now, we can write the complex power injection into bus k S k is equal to P k plus j q k, and this is equal to V k into I k conjugate. Now, I k conjugate we can write from here will be conjugate of this. So, we can write P k plus j q k is equal to this V k into this term is for I k. So, I k conjugate. So, conjugate of this term, where this can be written for all the bus bars, that is k can be from 1 to n. So, we can write this kind of a equation, that is the real and reactive power injection at any bus k can be written in this form. Now, we know V n, or the voltage at bus n, is a phasor, and it is equal to V n, the magnitude, into e to the power j delta this should be j delta n. J delta n. So, V n is equal to V n magnitude into e to the power j delta n. This k should not be here. E j delta n, and y k n, the admittance, is equal to magnitude y k n into e to the power j theta k n, where theta k n is the angle of the impedance. We have the impedance written as r plus j x, and the admittance will be 1 by r plus j x, which we can write as g minus j b. Therefore, we will have an angle depending on the magnitude of g and b for this admittance. So, we have y k n is equal to y k n magnitude into e to the power j theta k n. So, substituting the phasor V n and for the admittance vector y k n, we can write P k plus j q k, the real and reactive power injection at bus k, is equal to V k, which is the phasor V k, into summation y k n into V n e to the power j delta k is the angle for this, delta n is the angle for this minus delta n, because this part was our conjugate. So, conjugate means the magnitude remains same, the angle becomes negative. So, minus delta n into y k n was here. So, y k n we are writing with y k n with an angle minus theta k n, because this term is, this whole term is conjugate we have to take. So, these angles theta n and theta k n are negative. So, this is what we get from here, and if we now separate out the real and reactive part from this equation, then we can write P k is equal to V k summation n is equal to 1 to capital N y k n V n cos of delta k minus delta n minus theta k n. I am sorry, here this k is missing in this, and q k is equal to V k summation from n small n is equal to 1 to capital N y k n V n sin delta k minus delta n minus theta k n. So, we have the real and reactive power separated, and we can write the relationship between the real power and the reactive power in terms of the voltage magnitude and the angles at different bus bars and the admittance which is connecting the various bus bars in the system. That is real and reactive power equations are given like this. These equations are relating the real power and the reactive power with voltages at various bus bars V k, V n, where n is changing for all the bus bars, and y k n where y k n is the admittance which is connecting the bus k to all the other bus bars. So, let us see what is the characteristics of these power flow equations. Some of the important characteristics are that these power flow equations are algebraic equations. That is, if we see these equations are algebraic equations because there is no derivatives involved here or differentials involved here. So, these are just algebraic equations because we are using a static system condition. So, there is no differential equations involved, it is only an algebraic equation. Now, power flow equations are also, we see they are non-linear. That is, we have, if you look here, sine and cos terms involved here. Also, we have multiplication of V terms and so on. Therefore, these are non-linear algebraic equations. Since these equations are non-linear, the general procedure for solving these equations will be an iterative solution procedure. So, these power flow equations relate the PQ injections at any bus bar in terms of V and delta, the voltage magnitude and angle at various bus bars, and the Y bus elements. That is, PQ are a function of V and delta.